Sorry? It's flicker now. I don't know where it is now. I haven't clicked it. Is it your pocket? Good morning. So welcome. My name's Mike Room, head myself and Sachin are on the organising committee of the BCS Enterprise Architect Group. And Sachin has kindly volunteered to speak today, so Enterprise Data Architecture. Over to you.
Thank you, Mike. So I'm Sachin Bansal. I'm the Advisory Architect and Solution Manager for IBM. So today, topic I'll be covering is Enterprise Data Architecture. So within that, we'll be covering key aspects and pitfalls. So in terms of agenda, introduction, background, why Enterprise Data Architecture, what are the key aspects that need to be considered. Third thing I thought was case studies or group exercise. We don't have time to do that, and finally that one closes on e-course. So moving over, so about myself, so 20 years in-depth experience into IT. I worked with, currently I'm working with IBM, previously I was with BBC, Alcatel, Standard, Siemens. So a lot of large systems integrators, lots of participation, large complex transformation programs where I was exposed to enterprise systems. So as Mike said, also part of the committee for enterprise architecture specialist group as an membership secretary. I do some of the charity work, for profit organizations. So first, a bit about myself. Okay, so starting from an enterprise point of view, what do you think of as an enterprise? Again, everybody has their own opinion on what the size of enterprise should be. Some people think 50 million, some people think 1 billion, 500 million, or biggest enterprise like of Google or Ford's 100 billion plus. So again, if you think of key aspects, a set of collection of organization unit that share a set of common goals and provide specific products or services to the customer. So that's the definition of enterprise on a high level. Again, it's got a couple of elements that make an enterprise: people, process, functions, products and services, business strategy, and in terms of IT, data, application, and technology. So all of these require special focus from this perspective, but today we'll be focusing on the data aspects. So let's consider large manufacturing organization of electronic products. What are the key aspects of data? What would the data of that organization? So huge amount of sets of data ranging from customers, product, suppliers, dealers, parts, manufacturers, manufacturing plants, data which is coming from IoT devices, sensors in the fields, logistics, shipping, compliance, locations. Again, the main thing here is it's a complex set of data in various formats and covers areas of right from CRM, supply chain management, enterprise resource planning, or human capital management. Every organization has to kind of comply with legal regulatory compliance. It has to maintain industry-specific data, industry-specific policies, or anything that is specific to that industry. So from that, you can see that there is a lot of sets of data. Again, each data has its own value and its lifetime and validity, and that's one of the key aspects that we'll see from data architecture. Okay. So given that lots of complex set of data, and we also know that the data is continuously increasing, new sources of data like of IoT are coming, sensors in the field, and we have social media data, customer data is continuously growing, more and more compliance and regulation requirements to store and retain data for longer periods of time. So enterprises are facing data explosion. The data is doubling every 18 months to 2 years. They are facing increasing regulatory compliance, audit requirements, controls, and we have new sources of data which are coming. So previously it used to be standard text data, and now it is images, audios, videos, high resolutions, definition of data. Again, the volume of data is increasing manifold. So we are anticipating that the volume of data globally will go into zettabytes, approximately 40 zettabytes by 2020 or something like that. That's our IDC's prediction. So main thing is you need policies and procedures to manage all this volume of data. That's a key aspect of enterprise architecture. Okay, so One was a big volume of data that is challenges facing the enterprise. We also have new and changing business landscapes, a new entrance into the market, likes of Uber, Facebook, Alibaba, Airbnb. These companies don't have any products, they don't manufacture anything, they don't have any assets or any inventory, but what they are acting as is data integrity, data brokers. They are aggregating data from various sources, providing products and services, building a platform on top of that. So they are monetizing the data which they are collecting from various sources. So again, changing business landscape, which is in competition, causing a speed. And then, how can organizations kind of deal with the challenges? So deal with challenges, they have the enormous amount of data, and they need to consider that data as an asset, and they need to monetize it. So new paradigms are coming. Data is a new oil. So again, data coming from various sources. Well, you can have the data from various sources, but until you analyze it, you create meaningful insights from that one, it's of no use. So again, analogy to the oil, that you need to extract the oil, refine it, process it to get the value out of it. Same thing, terminology, paradigm applies to now data, huge volumes of data that is being generated. A bit of comparison of Google and ExxonMobil from a, like you can see that ExxonMobil 368 billion market cap, Google having 373, but if you see the difference in physical assets, 251 billion and 24 billion in physical assets, and the revenues, ExxonMobil took 137 years to reach that value, Google just around 50 years. Again, it's all about data. So data is kind of impacting every industry, right? From travel and transportation, where you are kind of optimizing data from engines, from aircrafts, again to power plants, where optimizations is being done, to transport planning. So in case of healthcare and pharma, drug discovery, healthcare, improved healthcare. So all set of industries are being impacted by the data. Again, you can use the big data to make informed decisions, optimize the processes, reduce the cost, and reduce the risk and efficiency. So these are the key aspects of data, the value that needs to be realized. So main challenge for the enterprise is to get the value out of the enormous data that they have, whether it's structured or unstructured or various formats. Okay, so that was the background and context of it. Let's go slightly bit deeper into what are the key aspects that enterprise data architect needs to consider. So quick poll, how many data architects do we have in the room? Okay. How many architects in general? So, see? Okay, so enterprise architecture framework. So moving from what the context of organization was, how do we move towards the enterprise architecture? Again, within EA, there are multiple frameworks, TOGAF, Sachin, and all of these frameworks, TODAF or MODAF, again, have their own way of addressing the enterprise architecture of an organization. So the key fundamental aspects of an organization, in terms of TOGAF, focus on requirements management and change around that. In terms of business data architecture, Zachman, again, data is a fundamental aspect. Within TOGAF, you have information systems architecture, which is focusing more on the application and the data aspects of it. But out of all the various architecture framework, we have still the main key themes are 4 types of architecture: business, applications, data, and technology architecture. So again, today our focus would be on the data architecture aspects of it. Okay, so now we have identified 4 types of key architecture areas: business, data, application, and technology. Again, key themes are that you need to have a layered architecture in place, common to all architecture frameworks. Key themes are that you need to have business layers with business competencies, business processes. On the application layer, you will have application services components, and on the data layer, you will have data services, data management aspects of it, and on the technology layer, you have technology platform components, technology components, and infrastructure part of it. All these layers integrate with each other as part of the enterprise architecture of enterprise. So, going forward with the enterprise data architecture. Now I've tried to drill down further into various aspects of the architecture. I won't go into business application and technology, but in terms of data architecture, what are the key things that need to be considered? So data entities, logical data model, physical data model, and data flow model. Again, very key things that define the data architecture on top level. In addition to that, you have management and governance related things. So aspects of change management, likes of you have transition architecture, you have target architecture, you have baseline architecture. Those need to be considered in change management. Policies, policies related to how you manage your data. Again, whether it's transactional data, operational data, analytical data, standards and guidelines, any specific standards to be followed, which are either technology standards, industry standards, aspects of data quality, so that's fit for purpose, aspects of life cycle of data, any insights, which is the analytics part of it, and access and security of data. So these are the key things which I think need to be addressed from an enterprise data architecture point of view. Again, they interact, these entities have some sort of relationship with application architecture, platform services, and would relate to business architecture as well, but we'll see on the slides. So enterprise data principles. So again, after we have seen data architecture, key concepts, what are key things that need to be considered. So I believe the starting point typically in an organization is data principles. So most of the organizations, if you go and try to kind of review their data architectures, they don't have written down data principles. Or if they are written down, nobody knows where they are written down. Or if they are kind of, even though published, people are not using it. So again, three things. You start with the business strategy, drivers and goals. Out of that, you create your IT strategy within that enterprise principle or architecture principles. And from that, you drive your data principles. So very simple. Data principles, general set of rules and guidelines to help an organization fulfill its mission. Again, key data principles. Around 5 or 6 of them. Again, organization can always stay with them. These are the generic ones. So data is an asset that is value to the enterprise. Users should have access to the data to perform their functions. And we have data trustee, which is accountable for the data quality. And data is used, defined consistently across the organization, and has a common vocabulary. Now, the common vocabulary is very important because within the size of a large enterprise, every department, every business unit have their own terminology of the data. They tend to use different terms, and within IT, even within IT, the terms are different depending on the architect, depending on the designer, depending on operation people. They tend to use different vocabulary. So again, should be defined consistently, and definitions are basically clear and available to all users. And last one, data is protected from unauthorized use and disclosure. So again, that's related to data security aspects of it, to say it's accessible to the relevant users and shouldn't be accessible to the unauthorized user. So these are the key enterprise data principles. Organizations tend to add more of them depending on their context. So anything specific to the quality aspects, or to make it more specific, anything relevant to their industry, they can add on more data principles. These are the generic ones, and it's a good starting point to start with data architecture to have that data principles written down. Okay. So now we covered the data principle aspects of it. The next part is the data entities and data models. So that's another set of deliverable from an enterprise architect. Again, it's just the key things that should be captured down from when we are creating an enterprise data architecture. So data entities, objects or concepts which are uniquely identified. So example, customer, products, services, customer addresses. Now, data entities, once you have identified, you can create a conceptual data model, which is abstract form of data model, to communicate ideas to the various stakeholders. So you have customer and customer addresses with a relationship of one to many. So customer can have multiple addresses basically. So you can see that it's a simple representation. and very intuitive to communicate to the other people to say, we have this kind of concept, this is what the data is, this is what the relationship between the data is. Again, from conceptual model, data model, you create a logical data model, so which is a slightly elaborate description, representation of the entities in terms of the detailed structure. The customer would have names, surname, date of birth, email, and some phone number, etc. In terms of customer address, it will have address line, whether it's active, state, country, state, and any comments that can be added. So that's a logical model. Key thing about logical data model means that it is platform independent. So any aspects of what the physical representation is not there. That's part of the next part, which is the physical data model. So physical data model is visual representation of the data, but still again in terms of how it will be implemented by the database management system. So whether certain attributes of a data are string, characters, what is their limit, what is primary key, what is foreign keys, what are the tables, what are the columns. So those are the key aspects that need to be considered into a physical data model. Again, one aspect of representation of physical data model is you can automatically generate data definition language out of it actually using tools. There are tools, enterprise architecture tools. Once you have created your data model, you can create DDLs automatically, and that can be applied straight away. Next one is data flow diagrams. Again, these need to be considered from an enterprise point of view. Simply visual representation of the data as it flows through the system, it includes the processes, the data stores, and entities. So data entity is customer. Again, you have process, receive order, and you have kind of functions that form order, invalid order, the data access to data to say customer places an order received, and all invalid order goes back to the data store. A simple representation of customer to shipping and payments process, but this needs to be considered again on an enterprise level actually. It maps the processes, business processes to data flow, so you can see clearly what are the internal data flows. So these ones are external stores, these are internal stores. So basically, it's a data flow diagram standard convention. You have something called as EML activity diagrams as well. Sometimes they are also used to represent the data flows. However, these are pure standards based, so data flow diagrams and EML standards. Most of the architects I've seen tend to use standard box and lines this thing, which is much more easier to use. Even myself, I've used that a couple of times actually just to represent how the data flows. The main thing is either you have enterprise flow of the data which you can visually represent. The diagrams are very, very complex because enterprises can be large. Or you have a segment or domain of an organization unit where you can say this is the data flow model. So whether the financial services model or logistics data flow model or customer relationship management data flow model, all those sort of data models are part of it. So we covered basic data principles, we covered data entities, logical, physical representation, and the data flow model. That is one of the, I think, core aspects initially of the enterprise data architecture. Once you have done that, you would be surprised to know that a lot of organizations don't have even the basic aspects of the data architecture documented or published or something like that. Now there are a lot of other things which go into the management and governance aspects and the lifecycle aspects, which you will see, but the core aspect of the data architecture is covered into these ones. Now let's see elaboration of further parts. So we identified a lot of layers are there in the business architecture. In the business architecture, so enterprise architecture is sort of made up of layers. Business within business architecture, you have business processes, and within application layer, you have systems. So business system mapping to data entities mapping. This is done as a CRUD matrix. I'm sure you'll be knowing CRUD. Anybody definition of CRUD? What is CRUD?
Gregory looked data.
Yes. So basic operations on data, create is insert, select, delete, update operations in the relational database. So you, on one hand, you have the use cases or entity processes or receive customer order, process customer order, and on the right hand side you have data entity, which is customer order, customer invoice, product, what are the operations which are done onto entities, various entities, by different business process or use case. Again, sometimes you can have a system mapping to the data, to say CRM will perform CRUD onto complaint, which is trouble ticket, or faults, and ERP would also do a CRUD onto, let's say, faults or complaint resolution, and commerce engine would be doing CRUD operation onto order aspects of it. So again, very simple representation, but very useful from a system analysis point of view. Again, so key aspects. The CRUD matrix can be used to identify heavily used data sets. So if you see a lot of columns being filled up against a particular data entity, you can clearly say that a lot of business processes and use cases are using that particular data entity. And you can also, again, some of the tools allow auto generation of the code. So let's move on to the data transition architecture. So again, we have the, as part of the architecture development work, data architecture, we would like to have to see if there is a request for architecture work, then you need to kind of identify what is your baseline architecture, what is your target architecture, and what is your transition architecture. So again, you should have a representation of what your as is to be and transition architecture is. Again, that's a deliverable from a data architect to say how the data would flow. Again, how you can do the data migration aspects. So if you have data about tickets, for example, you have to move the data, migrate to another ticketing system. You can take you can integrate the data, extract it, and load it into the new system. So you will have a transition architecture. So now this is a simplified view of transition architecture. Typically, enterprise-wide transition architecture looks like this. Roadmaps, you have the roadmaps, complex roadmaps. So current state, transition state, enterprise data architecture will have multiple transition states. And typically, key thing is it covers the whole enterprise, and duration likely to span several years. So as new capabilities need to be introduced, old capabilities need to be removed. It's a lengthy process. So that's a key aspect of it. Okay, so enterprise data related assets catalog, that's another catalog which is maintained by enterprise data architect. So you have few things which you have data related. So you have, for example, free client, free implementation for RDBMS client. You would have a RAG statement that says do not use. Again, it has several security issues or potential malware or virus. You have some example, open RDBMS would say approval required because it has got performance issues, or it doesn't allow certain type of licensing which would be required for commercial use.